Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand fuzzy set qualitative comparative analysis, also known as fsQCA. Fuzzy set qualitative comparative analysis is a methodology used in social science research and decision making processes to analyze and understand complex causal relationship among variables. It combines elements from fuzzy logic and set theory to handle imprecise or vague data, allowing researchers to explore causal patterns in situations where traditional binary logic or quantitative methods might not be appropriate. Let's start with a very simple question. How frequently do you watch movie? This question we are asking to the respondents, and the options given are quite frequently, frequently, sometimes, never. What is the problem in the above question? For some respondents, quite frequently is once a week, and for some respondents, quite frequently is once a month. Ambiguity arises due to varying interpretations of quite frequently among respondents. Some consider quite frequently as once a week, while others consider it as once a month. Consequently, there are overlapping answers for the question, overlapping responses, and fuzzy logic. So instead of just saying yes or no to whether you watch movie or not, fuzzy logic lets you express how frequently do you watch the movie. Unlike classical or binary logic, where propositions are either true or false, fuzzy logic allows for the degrees of truth or membership between the two extremes. Fuzzy logic is particularly useful in situations where the boundaries between the categories are not well defined and where the information is incomplete or vague. Let's take another example. Is it a hot water? And if the answer is yes or no, it's a Boolean logic. Now, the same question, the answer can be very much, little, very less, and depending upon the thresholds which we specify, that is zero point 0.9, 0.25, and zero point 0.1. This is known as a fuzzy logic. Fuzzy rules. In fuzzy logic, variables and categories are described using membership functions. These functions assign degree of membership to elements within a certain category. For example, instead of saying something is either hot or cold, a fuzzy logic system might assign a degree of membership to the category warm. Linguistic term. Fuzzy logic uses linguistic term to describe values like very hot, moderately warm, or slightly cold. This term captures the nuances of the situations more effectively than the binary labels. Fuzzy rules. Fuzzy logic systems use a set of rules to make decisions or draw conclusions. These rules are typically in the form of if-then statements that relate different input variables to output variable. Each rule specifies how the degree of membership in the input category influences the degree of membership in the output category. Concept of fsQCA and its usefulness. Fuzzy set qualitative comparative analysis is like using a tool that understands things that are just always not black and white. It is like saying, well, some factors matter more than others, and some people are kinda happy with their jobs while others are really, really happy. It's like giving each factor a score to show how much it matters. Then we mix and match the scores for different factors to see what combination leads to people being really happy with their jobs. Using this approach, we can handle situations where things are not clear cut and where different factors together create a certain result. It helps us to see the bigger picture and understand that life is not always just say yes or no or black and white. Let us take another example. What are the ways to get relaxed? Listening the soft music, relaxing on the chair, drinking tea, and moving out in the garden or reading the good book. Now, some require all these items to get relaxed. Some require all these items, but the strengths are different to get relaxed. Some require few items to get relaxed. So, for some people, only chair and tea is enough to get relaxed. And for some people, only tea can give the relaxation. Sometimes a decrease in a particular item or its absence can decrease the relaxation. Here, tea is absent and therefore the relaxation can decrease. Sometimes a decrease in particular item, that is now the music is also not there and the tea is also not there and the book is also not there. So this also decreases the relaxation. So on this basis, we will create the truth table. Presence of chair, music, tea, garden, book leads to the relaxation. presence of chair, music. T, the strength is more, garden, and book leads to the relaxation. For some people, for some cases, the combination of chair and tea. I'm using the word combination. The combination of chair and tea is enough to get the relaxation. For some cases, only tea is required for the relaxation. In some cases, the absence of music and absence of book leads to the absence of relaxation. So the yellow ones are the presence of the condition, red one are the absence of the conditions. Black cells, that is the cells which are blank, are don't care. Now on this basis, we will create the truth table, which will be coded in -1, 0, and 1. 1 means the presence of the condition, 0 means the absence. Minus 0 means don't care, and -1 is the absence of condition. Here 0 is don't care, and -1 is the absence of the condition. Now let's talk about the first one. Chair, music, tea, garden, book. So for some cases, for some people, this path is necessary to get the relaxation. All 5 are necessary. For some, chair and tea combination is necessary for the relaxation. For some of them, only tea is necessary for the relaxation. In some cases, the absence of tea leads to the absence of relaxation. In some cases, the absence of music, absence of tea, absence of book leads to the absence of relaxation. So on this basis, we will talk about the necessary and the sufficient condition. T leads to the relaxation. What does it mean? T is necessary for the relaxation. The second one, chair asterisk T leads to the relaxation. So this is Boolean multiplication. T is necessary but not sufficient for the relaxation. So here asterisk works as N, which means that the presence of both of them is necessary for relaxation. Plus, in case of Boolean, works as OR. So chair plus T leads to the relaxation. So T is sufficient but not necessary for relaxation. So here plus works as OR, which means that chair and T, either of them can provide the relaxation. Chair, asterisk music plus T, asterisk garden, asterisk book leads to the relaxation. So T is neither sufficient nor necessary for relaxation. So in Boolean algebra, addition indicates logical OR and multiplication indicates logical AND. So we are creating the fuzzy sets. T is necessary but not sufficient for relaxation. So here asterisk works as AND, which means presence of chair and T is necessary for relaxation. So it is A intersection B. T is sufficient but not necessary for relaxation. So here plus works as OR, which means chair and T, either of them can provide relaxation. So A union B. T, the absence of T, the negation of the T leads to the negation of the relaxation. Means the absence of T leads to the absence of relaxation. So it is A union B dash. Just as it is possible to calculate the logically possible number of combinations 2 raised to k, it is also possible to calculate the number of logically possible groupings. The formula is 5 raised to 3 minus 1, where k is again the number of attributes. Now what does this 5 stands for? T, music, chair, garden and book. And 3 stands for -1, 0, 1. 1, presence, -1, absence, 0, don't care. So combination of 5 aspects. T with music, garden, chair, book. This is one combination. The absence of T, music, garden, chair, book. T, absence of music, garden, chair, book. So this is the combination of 5 aspects. Similarly, you can create 4 aspects, 3 aspects. The combination logic. The data would support the idea that the presence of any one of the 5 conditions causes relaxation. Any one of them. But again, the data might indicate that the tea and chair gives relaxation only when the music and garden are present. When the music and garden are absent. You can see here, music is negative and garden is negative. Basically, this is a tilde sign. This means negative, the absence. Now, what are the basic steps of fsQCA? Sample is there. We choose the thresholds to calibrate the data. On that basis, the truth table is created. Now, we do the sorting of the truth table by frequency and consistency. Solutions are generated. We combine parsimonious and intermediate solutions, and then we report the fsQCA findings. Calibration. So, calibration is an important step in fuzzy set qualitative comparative analysis to ensure that the membership values assigned to fuzzy set accurately reflect the underlying data and the researcher's understanding of the variables being analyzed. Calibrations helps align the fuzzy membership values with the real-world context, improving the validity and the reliability of the fsQCA analysis. So here is the reason why calibration is necessary. Calibration. That we transform the data into the fuzzy sets. How we can do it? The researcher must specify the values of an interval scale variable that corresponds to three qualitative breakpoints that structure a fuzzy set. The threshold for full membership, the threshold for full non-membership, and the crossover point. For full membership, the fuzzy score is 0.95. For full non-membership, the fuzzy score is 0.05. And for the crossover point, it is zero point 0.5. These three benchmarks are used to transform the original ratio or interval scale values into fuzzy membership scores using transformations based on the log odds of full membership. Some researchers also take maximum, average, and minimum values for calibrating the data. Calibration in Likert scale. In the case of widely used 7-point Likert scale, where 1 is not at all and 7 is very much, previous studies suggest that the values of 6, 4, and 2 can be used as thresholds. Similarly, for 5-point Likert scale, the thresholds could be 4, 3, and 2. 4, 3, and 2. Remember, fsQCA does not test for construct reliability and validity, as this test refer to the measures and not the methods of analysis. If the constructs used in the study needs to be tested for the reliability and validity, then this is done prior to fsQCA analysis, following the traditional methods, and must be reported accordingly. Now let's see how we can carry out this analysis. So first of all, we will have to download the software. We will go in Google and we will write down fsQCA download. We'll click on this first link, fsQCA software. Depending upon your version, that is Windows or Mac, you click here and you will get the exe file. You run this exe file from here and the interface is ready. First of all, we will have to fetch the data. How we can do it? I'll go in File, Open, and click on Data, Open. So here is a file. Now we want to see what are the factors which affect the current salary of an employee. So these are the employees. These IDs are of the employee. The current salary is a dependent variable. The education acquired by the employee is an independent variable. Salary begin is an independent variable. Job time, that is the employees with our company, with that is in how many months. The previous experience of the employee in months. So we want to see that the salary, the current salary, which is the factor, which is a variable, which contributes the most. Is it education, the beginning salary, the job time, or the previous experience? So we will go again in the Excel and we will try to find out the maximum, minimum, and average as we want to calibrate the data. So how we can do it? So first of all, we will do for education. Our data starts from D2 and ends at 475. So 475. So I'll write down here a very simple command, maximum. Max D2 to D475. And this will give me the maximum value. Now I will take the average. D2 to D475. This will give me the average. Minimum value, mean D2, D475. I'm calculating all these three for calibrating the data. Now simply I will copy this in current salary, which will give me the maximum, minimum, and average salary, the beginning salary, job time, and the previous experience. Now, on this basis, we will calibrate the data. So, again, we will go back in the fsQCA interface. Right on, I'll activate variables compute. How can I calibrate the data? So, first of all, I'll start with education. I want to calibrate this. So, click on calibrate education. What is N1? N1 is a maximum value. N2 is an average value and N3 is a minimum value. We will give the name to this calibrated variable. So it will be now C education, that is calibrated education. What is N1? N1, I'll take 21 maximum. This is average and this is minimum. Let's take 21, 13 and 8. So I'll specify here 21, 13 and 8. Click OK. A new variable will be created, C education. You can see here, C education. Now we will repeat this process for the salary. Again, I will go in variables, compute, calibrate, salary. Now it will be named as calibrated salary. We want the maximum, average and minimum. Again, I'll go in the data set. 1,35,000, 34,419. So let's take 1,35,000, the maximum. What is the average? It is 34,400. Is it 34,400? Yeah, 34,400. I'm rounding off it. I'm taking a round figure. Then 15750 is the minimum. 15750. Click OK. Check. Is it calibrated? Yeah, it is calibrated. Now in your data set, if you are having any variable which is binary, that is 1 and 0, you don't need to calibrate it. You can see here minority is 1 and 0 and therefore it is not necessary to calibrate it. We'll go in analyze, truth table algorithm, C salary, set. You can do negate also, but here we are keeping it as a positive outcome. So C salary, that is now we will consider causal conditions, which is calibrated education, calibrated salary begin, calibrated job time, calibrated previous experience. So solutions cases and output. Do a small tick here, click OK. And you can see here we got the output. So 0, 0, 0, 0, 0. This means that this is an absence. And how many cases follow this condition? If you click here, you will get the cases which follow this condition. So there are many conditions, many outcomes, or rather many combinations have been generated. These outcomes or these combinations will be filtered on the basis of coverage. That is how many cases these particular combinations are covering. So we will specify the threshold. We'll go in edit, delete and code. So we want to inform that only consider those cases which are having consistency greater than 0.8. So it will filter out all those cases which don't satisfy this condition. Click OK. So you can see here on the basis of consistency, the cases have been filtered out. So C education present, C salary begin present, C job time present, C previous experience present, and click here. So there are 31 such cases which follow this condition. Here only 4 are there. And C education present, salary begin absent, job time absent, C previous experience present, only one cases. Only 7 cases are there. fsQCA and unobserved heterogeneity. fsQCA can address the unobserved heterogeneity to some extent. Unobserved heterogeneity refers to the variations or differences among cases in a data sets that are directly observed or unobserved, but it cannot be measured. Okay, it cannot be measured. Let me make a small change here. So let me read it again. Unobserved heterogeneity refers to the variations or differences among cases in a dataset that cannot be measured directly. These variations can potentially impact the analysis and interpretations of result. fsQCA offers certain features that can help handle unobserved heterogeneity, although researchers should be aware of its limitations as well. So let's say the presence of chair, music, tea, garden, book leads to relaxation in how many number of cases? So 50 such cases are there which require this combination. The combination of the second one, 45 such cases are there. The combination of third one, 34 such cases are there. So we are identifying the cases. Now, how is it useful? The causal condition is population aging, purchasing power parity per capita change rate, population growth rate, house price change rate, youth employment. These are causal conditions. We are discussing one paper that is using the FSQCA qualitative comparative analysis method to analyze the factors affecting the housing market. So these are the causal conditions, and this is the outcome condition. Now, this model, does it hold good uh, in different countries? So these are our cases. So all these factors affect the outcome conditions, or some factors affect the outcome conditions in China, and these factors are not present in India. These factors, what is the combination of these factors in Indonesia? We want to see this. So this is basically we are trying to capture the unobserved heterogeneity. It's exactly like the Herzberg's two-factor theory. Motivating factors increase employee job satisfaction. Poor hygiene factors decrease job satisfaction. So the absence leads to the decreased employee job satisfaction. So high motivation, high hygiene factor. So present leads to the motivation, or rather job satisfaction. High motivation, low hygiene factor. Again, it can lead to job satisfaction, but the absence of these two can decrease the job satisfaction. So it is the entire thing is about presence and absence. Now, the presence and absence of the core condition. Imagine you are trying to bake a cake. One of the core conditions could be having a flour. When you have a flour, you successfully bake a cake. So whenever you bake a cake, the outcome, you always have the flour, the core condition, as a part of the process. Flour is consistently present whenever you are baking a cake. The absence of core condition. If you don't have the flour, you cannot bake a cake. So whenever you cannot bake a cake, the outcome is absent. Flour, the core condition, is also absent. Flour is consistently absent whenever you are not baking a cake. Presence and absence of peripheral condition. Think of trying to add a rare fruit to this cake. A peripheral condition might be having a particular rare ingredient like a rare fruit. Sometimes when you make the cake, you might use that rare fruit to make it extra special. However, this does not happen all the time, only on certain occasions when you want that extra touch. Absence of peripheral conditions. Now, when you don't have that rare fruit, you can still make the cake without it. So, even if you cannot use the rare fruit, the peripheral condition, you can still make the cake sometimes. So, even in the absence of peripheral condition, the rare fruit, the outcome is present. The rare fruit is not always necessary for making the cake, but it's nice addition when you have to do it. Remember, core conditions are like the main ingredients you always need for the recipe, and they are always there when you need them, or always missing when you don't need them. Peripheral conditions are like special spices or toppings that you sometimes use to make things even better, but they are not essential every time. Let's try to understand this core and peripheral conditions by this flowchart. The outcome is baking a cake. Flour present can bake a cake. flour absent, cannot bake a cake. So this is our core condition. If the core conditions are present, then only we can talk about the peripheral conditions. IV2, the rare fruit present, adding rare fruit on special occasion. IV2 absent, rare fruit not available, but still you can bake a cake. Outcome, baking a cake, present. The coverage is high, consistently present, core condition. IV1, the flour, consistently absent, core condition. Now, when the core condition is present, we talk about the peripheral. IV2 present, the rare fruit, coverage high, consistently present, core condition. IV2 absent, the rare fruit absent, still the coverage will be high, consistently absent. This is known as a peripheral condition. The presence and absence of core condition. Imagine you are studying what constitutes the current salary of an employee. One core condition might be having a good starting salary. So whenever any employee is having a good current salary, it is likely that they also have a good starting salary. So C salary begin is a consistently present whenever the current salary is present. Absence of core condition. When any employee is not having a good current salary, it is also likely that they don't have a good starting salary. So C salary begin is consistently absent whenever C salary is absent. Presence and absence of peripheral condition. Now consider studying what factors lead to high current salary of an employee. A peripheral condition could be the combination of having a high education level and a high starting salary. C education, C salary begin. However, this specific combination does not happen very often. It's only in certain cases. Remember, core conditions are those that are consistently present or absent with the outcome, while peripheral conditions might contribute to specific situations but are not always necessary for the outcome to happen. The interpretation of this condition is based on the combination of data analysis, theoretical understanding, and the domain knowledge. Core conditions and peripheral conditions. fsQCA provides following three sets of solutions: complex solutions, parsimonious solutions, which includes the core conditions, intermediate solutions, which includes core and peripheral conditions. The complex solutions presents all the possible combinations of conditions when traditional logical operations are applied. The parsimonious solution is a simplified version of the complex solutions and presents the most important conditions which cannot be left out from LE solutions. These are called core conditions and are identified by fsQCA. Now let's see, where will I get my core and peripheral conditions? So I will go in the software. Here. One thing which I want to add is you can also calibrate any variable. Let's say we want to calibrate the salary. So here we have considered maximum, average, and minimum. But some researchers consider N1 as 0.95, N2 as 0.5, and N3 as 0.05. So these are also the thresholds which you can use. Now you go in this truth table. Click on standard analysis. Present or absent, these ticks are on. Just click OK. And you will get the result here. So the intermediate solution is there. And here you are having a parsimonious solution. So the parsimonious solution consists of the core conditions. And the intermediate solution consists of core as well as the peripheral. So here we are getting the output frequency cutoff 3, consistency cutoff 0.80, raw coverage, unique coverage, and consistency. We will interpret this, first of all, these values. So frequency cutoff. This indicates that only conditions with frequency greater than or equal to 3 are considered for the analysis. This helps filter out the conditions that are present in very few cases which might not be as relevant or meaningful. Consistency cutoff. This indicates the minimum level of consistency required for conditions to be considered in the solution. Consistency refers to how often a condition is present when the outcome is present and absent when the outcome is absent. A higher consistency value indicates a stronger relationship with the outcome. Raw coverage. This is a proportion of cases in which specific condition is present. For example, for the condition see salary begin, it is present in approximately 85.7% of cases. Unique coverage. This is a refined coverage measure that takes into account the unique combinations of conditions that lead to the outcome. It is generally a more conservative estimate of the condition's relevance. Consistency. This is the proportion of cases where condition is consistent with the outcome. For example, C salary begin is consistent in approximately 88.6% of cases. Solution coverage. This represents the overall coverage of the solutions, indicating how well the combinations of condition explains the outcome. In this case, the solution covers approximately 87.1% of the cases. Solution consistency. This represents the overall consistency of the solution, indicating how well the combination of condition consistently predicts the outcome. In this case, the solution has consistency of approximately 81.4%. Now, the biggest problem is to identify the core condition and the peripheral condition. The intermediate solution is a part of the complex solution and includes the parsimonious solution. While core conditions appear in both parsimonious and intermediate solutions, the conditions that are eliminated in parsimonious solutions and appear only in the intermediate solution are called peripheral conditions. I will explain this thing one by one. In other words, since the intermediate solutions presents both core and peripheral conditions, and peripheral conditions are removed from the parsimonious solutions, an easy way to identify the core condition is to examine the parsimonious solution, since it does not include the peripheral conditions. Let's try to understand this entire concept. We are having a parsimonious solution, this one. From where did I got this? From here. This is my parsimonious solution. This one. I've simply copied this on the slide, and this is my intermediate solution. This one. Okay. The first thing which I have to do is I have to identify the condition in the parsimonious which is having a high coverage and high consistency. So you can see here C salary begin. This is present in parsimonious as well as intermediate, and it is having a high raw coverage, unique coverage and consistency. So this is considered as core because it is retained in both the solutions and has consistent explanatory power. Let's talk about C education and C previous experience. Normally it is said that whatever conditions which are there in parsimonious solutions are core condition, but you have to take the decision on the basis of coverage. Though C education and C previous experience is present in parsimonious solution and as well as the intermediate solution, but its raw coverage, unique coverage and consistency is very much less. We conclude that it is a peripheral condition. Now, what are the thresholds which are considered for high coverage and consistency? Consistency, this figure should be above 0.74. Raw coverage should be between 0.25 to 0.65, and unique coverage, this one, should be above 0.1. This is recommended. Now, if these figures are less than, though this condition is in parsimonious solution, we will specify that this is a peripheral condition. Let's talk about the remaining two, these two. So, these conditions are present only in the intermediate solutions. C education into C salary begin and C salary begin into C previous experience. These conditions are present only in the intermediate solutions. While they have decent raw coverage, their unique coverage and consistency values are comparatively low. These conditions are peripheral because they do not meet the criteria to be retained in the parsimonious solutions. They are not there and have relatively weaker explanatory power. So what is a flowchart? The first thing you have to see is the parsimonious solution. If the condition is present in both of them, and if the coverage and consistency is good, it is a core condition. Now, second thing, if the condition is present in both of them, but the coverage and consistency is less, though it is in parsimonious solution, we will name it as a peripheral condition. After that, we will go in intermediate solutions. In this, there will be a conditions which will not be present in parsimonious solution, though their coverage is high and consistency is high, but they, as they are in intermediate solutions, they are no considered to be the peripheral conditions. So presence of core condition is indicated by a large black circle, presence of T necessary for relaxation. Absence of core condition is indicated by circle and cross. Absence of T leads to no relaxation. Presence of peripheral condition indicated by a small black circle. So the presence of T with chair gives a relaxation. Absence of peripheral condition is indicated by a small circle with cross. So presence of T and absence of chair can give the relaxation. Any condition whose presence of absence does not make presence or absence. Any condition whose presence or absence does not make difference is indicated by blank space. That is, don't care. So the type of food has nothing to do with the relaxation. So we will make this type of chart. Our C celery begin is having high raw coverage, unique coverage and consistency, and as it was present in parsimonious, we have indicated this by large black circle. All the remaining are indicated by small black circles. If we are having something to negate the absence, C celery begin, so that will be indicated by a circle with cross. Now there is one paper, the fuzzy set qualitative comparative analysis guidelines for research practice in information systems and marketing. It's the same paper from where we have taken the flow chart, this flow chart, and they have made this. Yeah. So how you report the fsQCA findings? So the large black circle indicates the presence of core condition. Small black circles, you can see here, small black circles indicate the presence of peripheral condition. Large circles with cross mark indicates the absence of core condition. Small circles with cross indicates the absence of peripheral condition. Blank space indicates don't care. Now we will analyze the necessary conditions for this data set. So we'll go and analyze necessary conditions, outcome. So our outcome is calibrated salary. We'll pick up this, add the condition. We'll check calibrated education. We will take calibrated beginning salary. You can take the negation also. You can take the negative also. Salary begin. See job time. See previous experience. And click OK. So I got this result. The consistency of C education and C salary begin is very, very high. Let us interpret this. So based on the provided information, this is the necessary condition which we generated in fsQCA software. You can see here the consistency of C education as well as C salary begin as well as its coverage is very high. So let's talk about C salary begin. This condition has a relatively high consistency and coverage. It appears to be a strong candidate for explaining the variations in the outcome variable C salary. Let's talk about C previous experience. This condition has a lower consistency compared to other. While it has a reasonable coverage, its consistency might indicate that it has a weaker relationship with the outcome variable. C job time. This condition has a moderate consistency and coverage. It seems to have a reasonably strong relationship with the outcome variable. C education. This condition has a highest consistency and good coverage. It appears to be a significant predictor of the outcome variable C salary. In summary, based on the provided consistency and coverage values, C salary begin and C education appears to be the strong necessary conditions for explaining the variations in the outcome variable C salary. Now what we will do, whatever results which we got in fsQCA, we'll go in Smart PLS, and we'll work on the same data set. New project. We'll include employee. We'll give the name employee, create, import the data file. So it is an employee data, open, import, press back, create the model. I'll name this as the regression model, and let's say it is employee data. Save. Now again, I'll consider the current salary as my dependent variable, education as my independent variable, beginning salary, independent variable, job time, and previous experience. And let's run this. Start the calculation. And standardized coefficients with p-value. You can see here, we got the same result. Salary begin and education. They are the variables which influence the current salary the most. So you can see that by two different methods, that is by using fsQCA and PLS-SEM, we are able to get the same result. Now, what is the next thing which you have to do is predictive analysis. To assess the predictability, a sequential process is typically followed. Initially, the sample is randomly divided into two segments, a subsample and a holdout sample. Consistent with the methodology outlined earlier, the same analysis is executed on both of these segments. The subsequent phase involves subjecting the subsample to the fsQCA analysis. The resultant findings from this analysis are then evaluated against the holdout sample. So we are comparing them. Incorporating the holdout samples into the assessment of the predictive validity is an essential practice. What are the implications of fsQCA? Researchers can benefit from using both methods in a mixed methods approach. PLS-SEM can provide insights into the strength and direction of the relationship between variables, while fsQCA can help identify different combinations of conditions that produce a particular outcome. The choice between PLS-SEM and fsQCA depends on the research question. If the aim is to understand the strength and direction of the relationship between variables within a structural model, PLS-SEM is more suitable. If the goal is to identify different pathways leading to an outcome based on different configurations of conditions, fsQCA is more appropriate. How to write findings comparing fsQCA and PLS-SEM on same sample. This I have taken from the paper. It's the same paper which we are discussing, which we have discussed previously also. The fuzzy set qualitative comparative analysis written by Pappas and Woodside. So these are the fsQCA findings and these are PLS-SEM findings. fsQCA findings. Quality of personalization is present in 6 out of 9 solutions that explains intentions to purchase. This can also be read as high quality of personalization explains intention to purchase in 6 out of 9 solutions or 9 cases. The same thing in PLS-SEM findings. Quality of personalization is an important predictor of intention to purchase. Benefits of personalization are present in 5 out of 9 solutions that explains intentions to purchase. Benefits of personalization are an important predictor of an intentions to purchase. Cognitive perceptions are more frequent present than absent when explaining intention to purchase. All cognitive perceptions influence intention to purchase. So you can generate the two results by using two different approaches and you can compare them. So this was all about fsQCA. For more videos on Smart PLS, you can subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos on structural equation modeling using MS as well as structural equation modeling using Smart PLS.